Take 2, function notation. Hello students. So this is our first lesson in our functions unit. It's on function notation. In this lesson, you will learn what is a function, how do we represent functions, what is function notation, and how do we evaluate functions. Now, a function is an expression, rule, or law that defines a relationship between one variable, the independent variable, and another variable, the dependent variable. Functions are everywhere in math and are essential for formulating physical relationships in the sciences. So you will hear independent variable and dependent variable a lot in your science class. Now, how do we represent functions? So we represent functions mainly in 3 or 4 different ways. So we can represent them with a function. You see here my x represents my input or my independent variable, and my y is my output or my dependent variable. And here are 2 different tables written, one written horizontally, the other written vertically. We can represent functions through the graphs. Now you notice certain features of a graphs. Graphs have y-intercepts where they pass through the y-axis, and they have x-intercepts where they pass through the x-axis. And we can also represent functions with equations. Here we have 2 common equations, y equals 3x plus 2 and y equals x squared minus 9. I hope you can already identify these equations, but we'll be working with them significantly in this year. Also, we can express functions verbally. So this function is rule would be add 3 to the previous value, and that would be defining a function. So not everything in math is a function. So sometimes you'll have a relationship that is not a function. So my key thing is it predictable? When you have this table here and you have the input of 3, you notice that we have 2 different outputs. So basically, this is not going to be predictable. When you put a value into a function, you should always only get out one other value. And you can see this represented in the graph where 2 points falling on a vertical line means that there are 2 outputs for that point, and these graphs are not functions. And sometimes equations do not represent functions. So in this case, if we knew the output of the function was 4, then there are 2 possible inputs, 2 and -2, that would give me an output of a 4. Function notation. As discussed, functions are a series of inputs and outputs. Usually in math class, your teacher will use x and y. But we can describe the output in another way, and that's using the term f of x. Now, basically, f is the name of the function. Sometimes just using y over and over again, you want to identify a specific function. So f is the name of the function, and x is the name of the variable. So whenever you see it, there's no need to be scared, because y is equal to f of x. They just say the same thing, just another way of describing the output. And of course, it's pronounced f of x. But there are other names that are good too. We can have h of t, a of x, g of u, t of smiley face. The letter on the outside is the name of the function, and the letter or symbol on the inside is the name of the variable. Now, with these functions, we can evaluate them. So evaluating functions simply means you're going to replace the variable x with a specific value. So if we have the function f of x is equal to 5x, or f of t is equal to t plus 2, or g of x is equal to x squared plus 3x plus 1, I can always replace these variables with a specific value. So we're going to be evaluating each of these functions for f of 4, and that simply means that x is equal to 4 in this case. So for this first one, instead of saying f of x, I'm going to replace it and say f of 4, which would be 5 times 4, which is equal to 20. We have, instead of t plus 2, I want to find the f of 4, so it would be 4 plus 2, which is equal to 6. And instead of saying g of x, I'm going to say g of 4, which is 4 squared plus 3 times 4 plus 1, or 16 plus 12 plus 1, which is equal to 29. So we say g of 4 is equal to 29. Now, of course, I could have picked a different value. I can also evaluate all these functions for, let's say, x is equal to 10. Well, in which case that will change all my outputs. So here, my f of 10 will be 5 times 10, which is equal to 50. And then my f of 10, for my next function, will be 10 plus 2, which is equal to 12. And, woo! So g of 10 would be 10 squared plus 3 times 10 plus 1, which is 100 plus 30 plus 1, or 131. So g of 10 is equal to 131. Now, on your own, I want you to answer 2 questions. I want to evaluate the function g of x for x is equal to 0, x is equal to 2, and x is equal to 3. Here is g of x. And then for 2 of the 3 representations, show a function, show a non-function, and then write to tell the difference. So write a paragraph, a couple sentences to tell the difference. All right. Thank you very much. All right.